Hi students, welcome to this video session. My name is Samuel Chukwu Emeka, aka Sam Dumb for Peace. In this video session, let us begin by going to my website and click on my picture to enter the site. Click on Mathematics, Finite Math under the notes. So we shall be doing some examples on interest, and some of you are audio visual learners, so you want to see how this could be solved using your calculator. So I'm going to solve these problems. These problems has been solved already. Let's begin with interest. If you click on this, you will see the questions have been solved, and I did some of them in fractions, and you really want to know how you can put in some of these with your calculator and get the answer right away. So I will use the calculator on my computer to show you that, okay? And some of you don't like fractions, so I did some of these problems using fractions, and some of you don't like these fractions right here. So you want another way to solve it, an easier way to solve it. So I'm going to show you that with the calculator on the computer. I will also want to talk about this calculator here, www.finance-calculators.appspot.com. We are going to use this right here to check our work as well. So I developed these calculators for you guys. You can use this to check your work. I will suggest that you don't use it to cheat. Okay, as you can see here, it is recommended that you have solved the questions first. You solve the questions with these formulas first, then you can now check your work with these calculators. Okay, I will show you how you can use them. It is recommended that you use the latest internet browsers, okay, but this works, it works well. And this is the website here, www.finance-calculators.appspot.com. So please, before you begin, it is highly recommended that you view the videos in the playlist. You know what simple interest is all about: compound interest, continuous compound interest, APY, annual percentage yield. It is important that you have viewed the videos in the playlist, and you can see it right here. If you go to videos, mathematics of finance, so you'll see the videos in the playlist here. All right, we shall begin right away. So these are the formulas here. So you are knowledgeable with these formulas because these are the prerequisite videos here. So I'm going to pull up the calculator on this computer. You can, if you're using Windows 10, you can just type in calculator, and it will come up, a desktop app. Usually it will come up like this, standard. Usually it comes up as standard, but you can just click on this and get scientific. Okay, if you are not using Windows 10, you can do this. You can go to this Windows icon and look for accessories, You look for accessories. It's usually under A. Is a folder under A, accessories, and under the accessories you can find the calculator. Okay, but if you're using Windows 10, just type in calculator here, and it is a desktop app, trusted Windows Store app. Just click on it. All right, so first question, we have this. 5.5 years ago, Peter invested $20,000 in a retirement fund that grew at the rate of 12.45% per year, compounded quarterly. How much does he have in his account today? So you will use the compound interest formula, and this is what I'm gonna do here. At least this, you know how to set up this, right? At least you know how to set up this. Yeah, once you know how to set up this, we're gonna use order of operations. So I assume that you are familiar with order of operations. If you are not familiar with the order of operations, then I will encourage you to go to mathematics, arithmetic, and you click the order of operations here. Integers, operations, and expressions. You can view the video here. Okay. So we get back to finite math under our notes, and this is solved examples on interest. Okay, so I assume that you know how to do this here, to set this here. So what we are gonna do is we first of all, let's do this exponent. 4 times 5.5 equal to, and that is 22. That is how I got this 22. We can actually write it down in our paper, or we can just save it in memory, M plus. Okay, I save it in memory by pressing M plus. Then I will have to do the parentheses here. 0.1245 divided by 4 equal to, if you are using this calculator, anything you do equal to. Anything you do equal to. Then plus 1 equal to. And then I'm gonna press x to the power y, okay, because it raises it 2. And I will recall the memory. I'll recall the memory I saved, which was 22. Okay, memory recall. And I press equal to. And then I do times 20,000 equal to. Okay, and that gives me this answer, $39,253.55. Because this is a money, dollars and cents, you have to round it to 2 decimal places. So if you want to check your answer here, just to make sure, this is compound interest and you are looking for the amount. So I'm gonna click compound interest right here, and I need to find the amount. Okay, I need to find the amount. The principal was 20,000. Rate is 12.45%, compounded quarterly. So this is 20,000. Rate is 12.45, right? 12.45%, compounded quarterly. And the time is 5.5 years. So 5.5 years. Okay, if you pick this years, and you just click calculate, and that gives you $39,253.55 as the amount. Okay, does that make sense? So if you use your calculator to do it, and you use this web app, this is a calculator, is also a web app, and you use it to do it, and you don't get the same thing, then there is a problem. Okay? It is either that I'm right and you're wrong, or that you're right and I'm wrong. But do it again. Okay? I will say do it again. Okay? Because I have tested this. I have tested it, but you know, I am a human being. I can make mistakes. Only God does not make mistake. So it's possible that I made mistakes. So, but do it again, and if you think that the calculator is wrong or something, just contact me. You can always contact me from here. You can always contact me here. Okay? The next, number 2, is finding the effective rate of interest. And we say that effective rate of interest is your APY. And this is the formula here for compound interest. And this is the formula for continuous compound interest, 2V. This is the formula for continuous compound interest. Okay, so let's do one of the problems on compound interest. Let's do the semi-annually, II, with the calculator. So I'm just going to clear entries, and I'm going to do MC to clear the memory. Because if you press memory recall, it's still 22. But I'm going to press the clear memory, MC, to clear it. Okay? And I press C to clear this. So this is the formula for APY, which is also known as the effective interest rate or true interest rate. I explained it in the videos on APY. So I'm gonna, this is the formula here. Let's do the semi-annually. This is the formula right here. This. So I believe you know how to put it like this for semi-annually. So I have 2 here, so let me keep it. I will start with the parentheses, 0.05 divided by 2 equal to, then plus 1 equal to, then squared. With squared, you can do x to the power y and press 2, or you can just press x squared right away. You can just press x squared right away. Then minus 1 equal to. And because APY is a rate, when we find it in decimal, but we have to multiply by 100 to keep it in percent, because it's a rate. Remember, with rates, when they give you rates, it is in percent usually, and when you want to use it, you convert to decimal. But when you are asked to find the rate, APY is true interest rate. When you find it in decimal, but in your final answer, you convert it back to percent. However, do as your professor wants you to do it, okay? But rate is in percent. So for my students, I want you to convert it back to percent. So you do that by multiplying by 100. And that gives us 5.0625%. Usually, your professor will inform you how many decimal places you want, he or she wants you to convert your APY. Okay, usually the professor lets you know. Let us do this with my calculator, my web app that I designed. And I'm going to press APY here. And I'm giving the semi-annually, I'm asked to find the effective rate for the APR. This is APR, annual percentage rate. But I'm asked to find the APY, annual percentage yield. For 5% per year, compounded semi-annually. So the rate is 5%, compounded semi-annually. Calculate. So that gives you 5.0625%. And that was the same thing here. It's just that I rounded here. Okay, so that is how you find it. And for continuously, the same thing, that is the way you do the rest of it here. For continuously, you can use this. This is the formula you use. So we are told that the rate is 5%, which is 0.05. If you look at this now, you don't see the exponential function here, e to the power x. That is what it should be. So, but you press this top arrow. When you press it, you will see more functions here. Okay, you see more functions here. So if you're using the calculator on the computer, you have to first of all press 0.05 first before you press E to that. There are some calculators that you are going to use and you don't need to press, you do not need to press 0.05 first. But if you're using a calculator on your computer, you have to press 0.05 first before you now press e to the power x, and it gives you this. Then you do -1 equal to, okay, and that gives you all these big numbers. Then you now multiply by 100 to give it to you in percent, and that is 5.1271%. I used 2 decimal places. And if you want to do it here for continuous compound interest, that means you're giving the rate and it's compounded continuously. So you go to here, rate is compounded continuously only. So because with how do you, some people will ask me, how do you differentiate? How do you find this? With this one, you have with compound interest, you have both the rate and the number of compounding periods per year. But with continuous compound interest, the APY is, you just have the rate only. So if you're using this to check, this is what you're gonna use, and you see this is just compounded continuously. But this one has the all other options. Okay, so we're gonna use this. The rate is 5% compounded continuously, and that is 5.1271%. I think that was what we got here, right? 5.1271%. So the next one is simple interest. Paul purchased $16,000 worth of 52-week T-bills, treasury bills, for $15,750. What would be the rate of return on his investment? So this is the formula you're going to use here. That is the formula you use. And then we've discussed all this in the previous videos. Okay. So with your calculator, I'm going to clear entries here. And I'm going to just press this arrow to switch it back to the normal thing. Here our A is 16,000. So you press 16,000. Then divided by P 15,750 equal to, you first of all do equal to, okay? And some of you might want to, if you're using your ordinary calculators, please, this is important. What I am about to say is very important. So some of you, when you're using your ordinary calculators, you tend to round these right away. You probably round it to 2 decimal places. Okay, let me say this. You do not round intermediate calculations. No, you do not do that. Okay, you don't do that. Now, usually the question will give you how many decimal places they want you to round your answer. If it says 2 decimal places, then what you might want to do, actually you're not supposed to round at all. But because this is a big number, and maybe you're not using the calculator on the computer, maybe you're using a TI, okay, or a Casio, and you, first of all, you do this, and it gave you this. Please, if the answer says round to 2 decimal places, then you might want to round your intermediate calculations to at least 5 decimal places. Okay, if you must round, then round it to at least 5 decimal places, so that by the time you do your final answer, it will be right with the 2 decimal places. However, if you decide to round intermediate calculations to 2 decimal places, when they say that your final answer has to be 2 decimal places, you might get it wrong. Trust me, you might. Okay, and mathematics of finance is something that we don't want to mess with. Even 1 cent counts. So when I give questions and my students, the answer they missed by 1 cent, I take away points. Because why? Do you know why? If you are a company, let's say you're Walmart, for instance, if every cashier keeps missing 1 cent, okay, if Walmart in a particular store keep losing 1 cent every hour, or keep losing 1 cent with every cashier, okay, for the whole transactions that are recorded in a day, if each cashier loses 1 cent, do you know how much that would be in a day? Do you know how much it will be in a month? So in the mathematics of finance, we don't want to mess with 1 cent. Besides, 1 cent can be used to feed somebody in Nigeria. So don't throw it away. Okay, you can use it to feed somebody in Nigeria and give him food to eat. Okay, or give her food to eat. So please don't throw 1 cent away. So that is why you have to be cautious with mathematics of finance. We want to be very correct to the number of decimal places that we are asked to. So if you are asked to round to 2 decimal places and you must round, you don't want to write all these, then you can start with intermediate calculations. You might write this as 1.01587, 5 decimal places. Okay, don't do it to 2 decimal places. Okay, but if you're doing it with a calculator on the computer, then use everything like it is. So I divided 16,000 divided by 15,750. He gave me this. Then I did -1 equal to. Then I now divide by T. Divided by 52 weeks means 1. Okay, it's 1 year. Because you have to convert your time to years. Equal to this. So, and I have to multiply by 100 because they're asking me for the rate. Times 100. And that is it. 1.59%. Okay. This is a case of simple interest. You can also use this calculator here to check your answer. Just click simple interest, and we're asked to find the rate. So I'm looking for rate. I'm giving the amount. So I'm giving amount and principal and time. So let me find the rate and interest. Okay, so the principal was 15,750, amount 16,000. So principal is 15,750. Time is 52 weeks. 52 weeks. Amount was 16,000. And I'm asked to find the rate. Okay, 1.5873. Yeah, in this one, what I did was the time I made it to be 4 decimal places, and the rate, I also made it to be 4 decimal places. While of course the interest, the principal, the amount, they are money. So you always want to make sure it is in 2 decimal places. Now, even if you're not asked to make it round it to 2 decimal places, it is highly recommended that you always round money to 2 decimal places. Okay. Let's see here. Another question. Now, with this time here, the next question: how long will it take an investment of $10,000 to double if the investment earns interest at the rate of 10% per year, compounded continuously? So this is continuous compound interest. We have done it in the videos on that. So this is the formula here. This is the formula here that we are going to use. We have in this case, the principal is $10,000. We want it to double. So doubling it will make the amount to be $20,000. So this is like saying ln 2 divided by the rate of interest is 10%, which is 0.1. So this is like saying ln 2 divided by 0.1. And I talked about ln in the video on continuous compound interest. So we look at this. How do we get ln? We know that ln is logarithm to base e, where e is the Euler number or Napier's constant. So we press this arrow right here. We see the ln. And as usual, we want to press 2 first before we press ln. Okay, that gives us this. You don't need to press equal to again here because you say it is ln 2. Then divided by 0.1. And that gives you this 6.93 years. Okay. With my calculator, I rounded it. It should be 6.9315 years. Okay, let's test it out. This should be continuous compound interest. Okay. So continuous compound interest. And I'm looking for the time. I'm giving amount, principal, and rate. So I'm looking for the time and interest. I'm giving principal, amount, and rate. So the principal was $10,000. The amount will now be $20,000. And the rate is 10%, right? 10%. 10%. You can also use 0.1 and in decimal, and it will be the same thing. So you see this is 6.9315 years. I rounded it to, for the rate and time, I rounded to 4 decimal places. Now, if you don't want to use 10%, you can use 0.1 and still, but you have to select decimal. And if you calculate it, it still gives you the same thing. And if you're doing multiple calculations, you can reset. You can reset the reset button will clear everything, and you begin again. Okay. Let's see here. Okay, number 5. Let's do this one. How long will it take an investment of $10,000 to double if the investment earns interest at the rate of 10% per year, compounded monthly? So this is similar to this. The only difference is that this is compounded continuously and this one is compounded monthly. So we're going to use the formula for compound interest to do this. And this is the formula right here. So I'm going to pull up the calculator. Let me clear entries. So the principal is $10,000. So the amount will be $20,000 because this is to double. Okay. So I have literally I have log 2 divided by m times log 1 plus r over m. So this is what I have here. Because 20,000 divided by 10,000 is 2. So with this case, I'm going to do this. I'm going to do the denominator first. Then I will save it in the memory. Then I will do the numerator. And then divided by, I record the memory. Okay. So let me start with this here. Parenthesis here. 0.1 divided by 12 equal to. Then I do plus 1 equal to. So I want to find log of this. So since this is lean, just press this again to get the log and just do log. So log of this is this right away. And then I do times 12. Times 12 equal to. So let me save this in the memory. That's the denominator. I save it in the memory. And then I know that 20,000 divided by 10,000 is 2. So in this case, I have to press 2 first, and I press log. So you see log 2. Then I do divided by memory recall. I recall the memory, and that is equal to. So this is 6.9603 years. Okay. And I can still do it here, but I'm going to use compound interest. Compound interest. In this case, I am giving the amount, principal, number of compounding periods per year, and the rate. So, and I'm asked to find the time. So to find time, I'm giving principal, amount, number of compounding periods per year, and the rate. So I'm going to use this. So the principal is $10,000, amount $20,000, rate is 10%. Now compounded monthly, that is monthly, right? Yeah, compounded monthly. Calculate. So this is the time right here. Okay, 6.9303. That's right. Question 6 is, look at question 6. Rita invested $10,000 in a mutual fund that pays interest on a daily basis. The balance in her account at the end of the 8 months, 8 months they want you to use 245 days, was $10,475.25. Find the effective rate at which Rita's account earned interest over this period. Assume a 365-day year. So this is a case of compound interest compounded daily, but we are asked to find the APY. So, but we need to find the interest rate first. So look at the formulas I used. I think this first method, I used the first method, which is more challenging method. This, if you look at this here, I'll do it with calculator. Okay. I will do this right now with calculator, so you see how I do it. And then the less challenging method is easier. I will also do this with calculator. Okay, so with this now, let's go ahead and do this with calculator right here. I will clear entries. If you look at this first, you know, you can cross out this right away. 365 times 245 over 365. I mean, it crosses out right away. If you do it, 365 times 245 equal to, and you divide by 365. I mean, this is multiplying fractions. It gives you 245 here. So what I'm going to do first is, let me, because this is highlighted, I still have memory stored. So let me just clear this memory. so it's no longer highlighted. Okay, when it's highlighted, you know that there is memory that is stored. Okay, clear this. I'm gonna do this first, then I divide by 245. So 10,475.25 divided by 10,000 equal to this. And I'm gonna do log of this, gives me this. Then I divide this by 245, gives me this. Okay. And then I need to do 10 to the power of that, 10 to the power of this. So I just press 10 to the x. That's all I do. I press it, it gives me this. And then I do minus 1. And here I have to do equal to, gives me this. And I multiply this by 365. 365 gives me this. So you see that 0.069178135 is a long thing. Okay, that's what it gives me. And you know, you can do it here also. In this case, this is a compounded daily, and you're asked to find the rates. So we are given the amount, principal, and then 365. So this is exact days. Okay, exact days is 365. Ordinary days is 360. So what we're gonna do here, I'm gonna use a compound interest first before I use APY. Okay, and compound interest, they gave us AP and M. So I'll use a compound interest is there. And I'm trying to find rate. They gave us AP and M. Principal amount, number of compounding periods per year. And they gave us time. They give us time. We didn't have. Yeah, they gave us time to be 245 days. Okay, 245 days. So I'm gonna use this here. So I'm gonna use this one here. The principal is 10,000. So I'll put 10,000 here. The amount is 10,475.25. 10,475.25. And this is compounded daily exact. The exact days is 365 days. Ordinary days is 360 days. So you take exact days, and amount is 240, and the time is 245 days exact. We want exact. Okay, calculate. So you see the rate here. Okay, because if you multiply this by 100, that gives you 6.9178%. Okay, see that? So that is what you want to select, since it's exact days we want. Then the next one is, you can use this, this is more challenging method, or you can use another method to find this if you want to do it like this. I'm going to clear the memories. I'm going to clear the entries here. If I'm using this here, I will first of all, I'll do, if you do this first, you will see that this is 1/245. Okay. So what I'm going to do is from here. So first of all, I'll do 1 divided by 245. 1 divided by 245 equal to. And I will save this in the memory. I save it in the memory. So this is highlighted. And then I'll do 10,475.25 divided by 10,000 equal to. And I'm going to raise this. I will raise it x to the y. Recall memory equal to. And I'll do -1 equal to Then I'll do times 365 equal to. So it gave us the same thing. Okay. And if you want to find the APY right from here, since we know our M, this is the formula we use here. So this is the R. So I'm going to use it like that. I will divide this by 365 equal to. Then I'll do plus 1 equal to. And I will raise it to 365 equal to. And then I'll do minus 1 equal to. So because this is a rate also, APY is still a rate, true interest rate. You multiply this by 100. And that gives you this. Okay? So that is the way you do it. This one, this one is pretty much straightforward. You can do this one, and also you can also do this because we have done an example like this. So you can do this. Principle, doing this. Okay, let's do this one. Principle. And this one is Southeast Bank pays simple interest at the rate of 6% per year. Did he deposit? So I'm gonna use the calculator here. Let me clear this first, and I will clear the memory. Okay, once I clear it, it's de-highlighted, or it's no longer bold. All right, so I will first of all do this because I'll do this denominator, and I'm gonna do the multiplication first before the addition, because that is the order of operations. So I will do 0.06 times 8 equal to, then divided by 12 equal to, then plus 1 equal to. And I'll save this in the memory. I'll save it in the memory. Then I will now do 1300 divided by recall memory equal to. And that is, you always want to, it is very important you round it to 2 decimal places, because this is the principle. Okay, this is a case of simple interest. Now if I have to use the calculator I did, you have to check simple interest here, and you're given the amount, rate, time, and you're asked to find the principal. So given amount, rate, time, given amount, rate, time, there you go, to find the principal. So the rate is 6%, the amount is 1300, the time is 8 months. Okay, rate is 6%, time is 8 months, and the amount is 1300. Calculate. Okay, so the principal is $1,250, $1,250. Okay. This one, question 9. Let's do. Yeah, this one we've done it. We've done a similar problem like this. Question 9. Okay, so try it. Question 10 is pretty much straightforward. Question 11 is, we've done a similar problem like this. Question 12, we've done a similar problem like this. Question 13, I think we've done a similar problem like this. Question 14, we've done a similar problem like this. Okay, well, question 14, we can Yeah, we can do question 14. At least we can do one section of this. We've not done this. I'm sorry. Let's do something like this, and you just do it for the rest of it. The inflation rates in the United States economy for 2004 through 2007 are 2.3%, 2.7%, 3.4%, and 3.2% respectively. What was the purchasing power of a dollar at the beginning of 2007 compared to that at the beginning of 2004? So this is a case of a compound interest compounded annually, but we have to find the principal or the present value. So if I just select this case here, just do this one right here. The amount is $1. The rate is 2.3%. So I will clear this, and I will clear the memory here. 1 times 1 is 1, so I can keep that. Then I do this one here, order of operations. I do 0.023. Of course, divided by 1 will be 0.023. Then I do plus 1. It gives me 1.023. If I raise it to 1, it's still 1. Okay. And I can save this in the memory. So this is bold now. Whenever you hit this becomes bold. Then you know that you saved it in memory. And you just do 1 divided by recall memory recall. And that gives you this 0.99517106. And you do this for, you do this because this is from 2004. You do it for 2005, 2006, and then 2007. Okay? And then you multiply all of them to give you the purchasing power of a dollar. If I, this one, you have to just do it, you have to do it for each of the years, and then you multiply. So, but if we do for 2004, just with the calculator on my site here, and this is compound interest, compounded annually, compound interest, and I'm looking for the principal. I'm giving the ARMT, okay, and I'm asked to find the principal. So I'm asked to find principal. I'm giving ARMT. Okay. So amount is $1. The rate is 2.3%. And this is compounded annually. And the time is 1 year. Okay. 1 year. Calculate. So the principal is 0.98. But with this particular last question, I suggest that you don't do this, because I rounded this right to 2 decimal places. This question particularly, you have to do it for 2004, 2005, 2006, 2007, and then you multiply everything. So you really don't want to round it up until the final answer, just like I said earlier. Okay, so thank you so much for listening to this video, and we will do annuities in another video. Okay, we're gonna do annuities in another video to show you how you can use the calculator on your computer, and you can also use the calculator, this web app. Another way you can find this web app, like I said, if you go to the notes here, it is www.finance-calculators.appspot.com, or you can go to my website, and if you click on a mathematics page, and you can click on calculators. Okay. All right. Thank you so much for listening, and you have a good night.